Good afternoon everybody. Today we will discuss about numerical problems on error and accuracy. Now first we will define what is an error. Error. If we are making physical measurements, then there is always an error involved in the measurement. The error is notated by using the symbol delta, and it is followed by the variable which is representing the quantity measured. For example, if we are measuring volume, then the error in the measurement of volume, it would be delta V. So, error is denoted by delta and the quantity which we are measuring, that is volume or maybe energy, maybe anything about which we are making physical measurement. Now we come to the important point, the types of error. What are the different types of error? First is gross or human error. Second type is random error. Third type is systematic error. Fourth type is constant error. Fifth type is absolute error, relative error, percentage error and limiting error. These three, gross error or human error, random error and systematic error, these three they are called static error, and rest are not static, they are depends upon the system. So like absolute error, we will derive some numericals based upon absolute error, relative error, percentage error and limiting error. So these four type of error, they are important for the numerical purpose. So we will mostly discuss these type of error because these are about the measurement. So we can easily measure it, these four type: absolute, relative, percentage and limiting error. So now we come to the numerical portion. Side by side we will study about the theory of these error, and side by side we will do the numerical portion. Now the example is to find the truncation error for y is equal to e raised power x if the first three terms are retained in the expansion. So this is an exponential series, y is equal to e raised power x. So its expansion you already know is 1 plus x square by 2 factorial plus x cube by 3 factorial and up to so on. So the question is, if we have to find the truncation error if we are retaining only first three terms. Retaining means keeping, if we are considering only first three terms. So the first three terms are, first term is 1, second term is x, third term is x square by 2 factorial. So the error comes out to be true value minus approximate value. True value is its expansion, full expansion up to infinite, 1 plus x square by 2 factorial plus x cube by 3 factorial up to so on, minus approximate value is only the three terms in the expansion. So the three terms are 1 plus x square by 2 factorial. So truncation error comes out to be the difference of true value and approximate value. So it comes out to be x cube by 3 factorial plus x4 by 4 factorial up to so on. So if x is small, then truncation error is small, very small, but if x is large, then this error is large. Now we come to the theory part of absolute, relative and percentage error. Since we have already studied this part, so I will review only the few things which are important for the numerical purpose here. So now the quantity delta z is called absolute error. It means delta is the delta denotes the error, z is the physical quantity which we are trying to measure. So, delta z is absolute error. Suppose z is true value, so delta z upon z is called relative error or fractional uncertainty. Next term is percentage error. Percentage error is the fractional error or the relative error multiplied by 100. So, delta z upon z into 100, this comes out to be the percentage error. In practice, either the percentage error or the absolute error may be provided. Either we are given the percentage error or the absolute error. Now, we will discuss the example where the percentage error is given or the absolute error is given. Like in machining, the tolerance in an engine part is usually given as an absolute error. So, for the machining purpose, absolute error is used, while for electronic components the percentage tolerance is given. So, we will review all these things again. Delta z is absolute error, delta z by z is relative error, delta z by z into 100, it is called percentage error. Either percentage error is used or absolute error is used for the technical purpose. So, for the machining, the tolerance is given by the absolute error, that is delta z, while for electronic component almost the tolerance is given in percentage error. So, depending on the which unit is given, so we can easily detect while it is an absolute error or percentage error or relative error, because the absolute error has the same unit of the physical quantity, while the relative error has no unit because it is a ratio of two quantities, and percentage error, it is clear, it is given in percentage. So, we can easily detect while it is an absolute error, relative error or percentage error. I hope this is clear to all of you. Next, we can calculate the absolute error in the simplest way is, it is denoted by here EA. E means error, E means absolute. So, absolute error is equal to true value minus approximate value. Suppose true value of the physical quantity is x and approximate value is x prime. So, the difference of these two, it is called absolute error. Next, we come to the relative error. We already know absolute error is true value minus approximate value. True value is x and approximate value is x prime. So, the relative error now we define, it is denoted by ER. R means relative, E means error. So, relative error, it is equal to absolute error divided by true value. Since the absolute error is x minus x prime and the true value is x, so the ratio of these two, this is called relative error. ER is equal to x minus x prime divided by x, where x is true value, x prime is approximate value. This relation I used for numerical purpose. Now, we come to the numerical portion of these two type of error. Absolute error, the difference between measured value and true value, it is referred to as absolute error, as we have already discussed this thing. Now, we come to the numerical portion. Assume that the analysis of an iron ore by some method, it gave 11.1%, while the true value was 12.1%. So, the absolute error is 11.1 minus 12.1 is minus 1.0%. This is absolute error. Now, we will define relative error and correspondingly its numerical. A relative error is the percentage of the absolute error to the true value, or we can define it the percentage error. For the argument above, we can calculate the relative error as relative error, or here we can definitely define the percentage error is equal to absolute error divided by true value into 100. Absolute error is minus 1.0, true value is 12.1 into 100. This is percentage error, minus 8.3%. This is percentage error. Next we come to the important point of relative accuracy. The percentage of the quotient of the observed result to the true value is called relative accuracy. That is how much we are accurate in the measurement of any physical quantity. So, the relative accuracy, it is defined to be absolute observed value upon true value into 100. So, the observed value is 11.1, true value is 12.1 into 100, it comes out to be 91.7%. This is relative accuracy. We will again define this slide little bit to make it clear. A relative accuracy, it is the percentage, so into 100 of the quotient of the observed result. So, this is observed value to the true value upon true value into 100. So, relative accuracy is observed value divided by true value into 100. It comes out to be 91.7%. Next, we can easily define the percentage error. EP means, P means percentage, E means error. EP is equal to 100 into ER is equal to 100 x minus x prime divided by x. Now we come to the numerical portion of absolute, relative and percentage error. Suppose 1.414 is used as an approximate value to the under root 2. Find the absolute, relative and percentage error. We know under 2 is 1.414, 21356 and so on. So, we will take only the few digits. Absolute error is defined as true value minus approximate value, while the true value is given here 1.414, 21356 minus approximate value is given 1.414. So, the absolute error is the minus of these two. It comes out to be 0.000021356. This is an absolute error in the measurement of under 2. If we take the approximate value is 1.414. So, we define absolute error. Now, we will discuss relative error and percentage error in the measurement. So, the relative error is defined as absolute error divided by true value. Absolute error we already discussed, 0.000021356 divided by true value. True value is this thing 1.414, 21356. Upon dividing these two, we will get relative error. So, relative error here comes out to be 0.151 into 10 raised power minus 3. This is relative error. Now, we will discuss percentage error. If we multiply a relative error by 100, then it gives the percentage error. EP is equal to ER into 100. ER is 0.151 into 10 raised power minus 3. Upon multiplying by 100, we will get 0.151 into 10 raised power minus 1. This is percentage error in the measurement of under root 2. Next, we come to the second numerical portion. Second numerical, here the example shown is that the true value of the measurement is 122 millimeter and expected value is 120 millimeter. So, we will have to find the absolute error, relative error and percentage error. So, the absolute error is true value minus expected value. True value is 122 millimeter and expected value is 120 millimeter. So the difference of these two will give absolute error. So the absolute error is equal to 122 minus 120 is equal to 2 millimeter. Now we will define relative error. A relative error is equal to absolute error divided by true value. Absolute error is 2 and true value is 122. So upon dividing these two, we will get relative error is equal to 0.017. So now we will discuss some important points. Since the absolute error is a difference of these two quantities, so it has same units as that of physical quantity. So the absolute error has some units, while the relative error, it is the division of these two quantities. So it has no units, it has only value. So relative error value is 0.017 here. Next is percentage error. Percentage error is nothing but relative error into 100. Relative error is 0.017 into 100, it is 1.7%. So these three definitions are used for the numerical purpose: absolute error, relative error and percentage error. Next numerical is, what is the relative error in the approximation of x is equal to 2 to x is equal to 1.98. So the relative error is true value is 1.98 and approximate value is 2. So 2 minus 1.98 divided by 1.98. So upon calculating these, we will get relative error is equal to 0.01010. Next we come to the error analysis, or we can call it propagation of errors. Now we will discuss the basic rules about the error calculation, like if we are adding two quantities or subtracting two quantities, how we can measure the total error in the total mathematical relation. So this is called propagation of errors. Suppose two measured quantities x and y, they have uncertainty delta x and delta y. Two physical quantities are x and y, while the uncertainty or the error is delta x or delta y. So this thing is important, plus minus. Uncertainty means either maybe it in plus or maybe minus. From the measured quantities, a new physical quantity z is calculated from x and y, maybe any relation, maybe x plus y or x minus y, x into y or x divided by y, any physical relation. So we have to calculate what is the uncertainty delta z in z. So we will discuss these basic rules about the calculation of uncertainty in the physical quantity z. All these examples use the propagation of error using average deviation or average error and standard deviation or standard error. Now we first come to the physical quantity z, which is the sum of two quantities x and y, or maybe the subtraction x minus y. Here point to be noted is that the physical quantity may be plus, may be minus, but the error comes out to be same, either plus or minus. So z is equal to x plus y or x minus y. Now we have to calculate the delta z. Assume that the uncertainty are arranged so as to make z as far from its true value as possible. So the average deviation delta z is equal to delta x mod plus delta y mod in both cases, either may be plus or minus. Error is always a plus quantity. With more than two numbers added or subtracted, we continue to add the uncertainties. So these two type are different type of error. First is average and second is standard deviation. So simply average error is the sum of delta x, delta y, delta z up to which the physical quantities. So total error in the measurement is equal to delta x plus delta y and so on. While if we take the standard deviation, then delta z is equal to delta x whole square plus delta y whole square up to so on. So these two different type of error are used. First one is average error and second type is standard deviation or standard error. Now we will do numerical portion based upon these two, average error and standard deviation. Now the example is AW physical quantity is equal to 4.52 plus minus 0.02 centimeter. This is the true value 4.52. 0.02 is uncertainty in the measurement of W physical quantity. X is 2 plus minus 0.2 centimeter. Y is 3 plus minus 0.6 centimeter. These three are physical quantities W, X and Y. Now we have to find the Z and its uncertainty. Z is equal to X plus Y minus W, it is given. So X is 2, its true value is 2, Y its true value is 3 and W its true value is 4.5. So upon calculating this relation, we will get 0.5 centimeter. Now based upon average error and standard deviation, we will calculate the uncertainty or we can call it error. So delta Z is equal to delta X plus delta Y plus delta W, because error is always a plus quantity. So delta X is 0.2, delta Y is 0.6 and delta W is 0.02. So upon adding these three, we will get average error is equal to 0.82. Here point to be noted is that the significant figures. So after decimal in the measurement of Z, after the decimal point there is only one significant figure. So in the error there should also be only one significant figure after the decimal. So 0.82, we will write 0.8 instead of 0.82. So Z is equal to its value, true value is 0.5 while the error is 0.8. So Z is equal to 0.5 plus minus 0.8 centimeter. It is with average error. But if we use the standard deviation formula, this formula delta Z is equal to delta X whole square plus delta Y whole square, then the error comes up to be 0.633. So upon applying the same rule, we will write here the 0.6. So Z is equal to 0.5 plus minus 0.6 centimeter. This is with standard deviation or standard error. This is the same point we have already discussed. Notice that we round the uncertainty to one significant figure and round the answer to match. So instead of 0.82, we will write 0.8 because of one significant figure after the decimal. So in the error there is same rule applicable. So after the decimal we will keep only one significant figure. Next is multiplication. multiplication by a number or the constant number. The example is as follows. The radius of the circle is x is equal to 3 plus minus 0.2 centimeter. This is true value of the radius. This is an error, 3 plus minus 0.2 centimeter. We have to find the circumference and its error. So, C is equal to 2 pi x is equal to 2 constant, pi is 22 by 7, x is 3. So, upon calculating we will get 18.850 centimeter. So, we will apply the same rule. After the decimal there is only one significant figure. So, we will keep only one significant figure. So, it comes out to be 18.8 only. Now, we will have to calculate the error in the measurement of circumference. So, delta C is equal to 2 pi delta x, 2 and pi is again constant, delta x is 0.2. So, upon calculating this thing we will get delta C is equal to 1.257 centimeter. So, circumference is 18.8 plus minus 1.3 centimeter. So, we again have to rounding the uncertainty to the two figure since it starts with a 1 and round the answer to match. So, after the decimal we will have only one significant figure. Next example is x is equal to 2 plus minus 0.2 centimeter and y is 3 plus minus 0.6 centimeter. We have to find z physical quantity which is given by x minus 2 by, and we have to calculate its error. This is physical quantity. So, z is equal to x minus 2 by, x is 2 and y is 3. So, 2 minus 2 into 3 is minus 4 centimeter. Now, we have to calculate its error. Delta z is equal to delta x plus 2 into delta y. Delta x is 0.2 plus 2 into delta y is 0.6. So, it comes out to be 0.2 plus 1.2 is equal to 1.4 centimeter. So, z is total value is minus 4 plus minus 1.4 centimeter. This is an average error, but if we calculate standard deviation instead of average error, then this value changes little bit. It comes out to be 0.9 centimeter. So, depending on which type of error we have to calculate, the need of the numerical. So, different values are there. This first value is for average error, minus 4 plus minus 1.4. Second is for standard deviation, minus 4 plus minus 0.9 centimeter. Next we come to the next point, that multiplication and division of two physical quantity. Like the same rule applicable for plus and minus, so here the same rule is applied for multiplication and division. So, we will now derive the uncertainty or error in the measurement of z physical quantity, which is multiplication of two quantities or the division of two quantities. Z plus minus delta z is equal to, z is x into y, so x plus minus delta x, y plus minus delta y. These are the error in the measurement of x and y. So, x into y plus x into delta y plus delta x into y plus delta x into delta y. So, upon multiplying these two terms, we will get these four terms, x y plus x delta y plus y delta x plus delta x delta y. Since we already know delta x and delta y, these two are very small, so their multiplication becomes very small, so we can neglect this term. So, z plus minus delta z is equal to xy plus x delta y plus y delta x. So upon calculating we will get z is equal to xy, z is equal to xy, while the error in the measurement is delta z is equal to y delta x plus x delta y. Upon dividing this equation by z,